In this experiment, the first step involves treating acetylsalicylic acid, or ASA, with sodium hydroxide to create the salicylate ion. The salicylate ion is then treated with a solution of iron 3+ to create the colored salicylate iron 3+ complex. For the purpose of this presentation, acetylsalicylic acid will be abbreviated as ASA, the salicylate ion as SA, the salicylate iron 3+ complex as SA-Fe3+. Note that the mole ratio is 1:1 for each transformation. You will be weighing approximately 325 milligrams of ASA, treating with excess sodium hydroxide and diluting it to a total volume of 250 milliliters, creating the SA solution. Since the moles of ASA can be calculated, the molarity of the SA solution can also be calculated. You will then be transferring 5 milliliters of the SA solution to a 100 milliliter volumetric flask and filling to the mark with iron 3+ solution, creating the dark purple colored salicylate iron 3+ complex. Note: normally water is the solvent and the blank, but in this case the 0.02 molar iron 3+ solution is the solvent in the blank, so the concentration 0.02 molar written on the bottle can effectively be ignored for all calculations. The concentration of the colored salicylate iron 3+ complex can now be calculated. Now, if you take the absorbance of the salicylate iron 3+ complex solution, you can calculate the molarity of the solution using the Beer-Lambert law and the standard curve, which was provided or previously created. If you know the molarity of the solution, you know the number of moles of the salicylate iron 3+ complex in the 100 milliliter solution. This is the same number of moles of the salicylate ion that was in the 5 milliliter sample. The total amount of salicylate ion in the original 250 milliliter sample can then be calculated. Since the reaction of ASA to SA is 1:1, if you know the moles of SA in the solution, you know how many moles of ASA was added to it. The mass of ASA can then be calculated.